Hello Physics 30s. Today I'm going to be demonstrating the data collection for your wavelength of a laser lab. I'm going to start the data collection with the red laser. However, I'll also use the green laser and the violet laser in order to for you to choose one of those data sets. There are 3 diffraction gratings that we'll be using. There will be a replica diffraction grating, which has 530 grooves per millimeter, so you can use that as your number of lines per millimeter when you have to record that on your data collection. There's also the glass diffraction grating, which has 600 lines per millimeter, so that you can record that under the glass diffraction grating. And then we'll also be using a CD, which has instead of being given a lines per millimeter, you're given that there are 1600 nanometers between the grooves. So those are the 3 diffraction gratings that we'll be using for this. For each of them, you may notice that along the ground, I have set up a meter stick that touches the wall and extends out a meter, and then there's another meter stick perpendicular to that. That will be my reference line. That will also be considered as the distance between the slits and the screen. So you can use 1 meter as your value for D. When we set up each of these experiments, I will stand so that the diffraction grating is right at the 1 meter mark. When I shine the laser through the diffraction grating, you will see, with the right orientation, you will see dots on the screen, on the board, and I will mark those dots and then take measurements between them so that you can use that as the separation distance between the bright fringes or the antinodes. But I'll turn off the light so you can see them better. Okay, this is the data collection for the replica grating. So when I turn the laser on, you should be able to see 3 distinct dots, plus there's some reflection in the background. Then I will mark where those dots are and measure the distances between them. Okay, once we marked the 3 spots, that central dot is the central maximum. The distances measured with a meter stick from the central maximum to the first order antinode on the left is 34.2 centimeters. The distance from the central maximum to the first order antinode on the right hand side is 35.0 centimeters. You can use that to perform your data collection. Okay, moving on to the glass diffraction grating. Standing at the same location, 1 meter away from the screen, 1 meter away from the board, we see a very similar diffraction pattern. I'll turn the lights off and mark the dots and then measure the distances. Glass diffraction grating, interference pattern. Okay, once we have marked the central maximum, I labeled because there's a first order maximum on either side and then a second order maximum on the right hand side that showed up. We don't need that value, you just need the first order antinode on either side. So the distances between the central maximum and each of those are 42.3 centimeters and 37.4 centimeters. Okay, now the last diffraction grating that we'll use is a reflective diffraction grating in a CD. So the CD has distances between the grooves of 1600 nanometers. You'll notice that the diffraction pattern that we get on the board is a little bit different than the replica grating and glass diffraction grating. I'll turn the lights off and take the measurements. Okay, the central maximum for this one is the dot at the center, and you may have noticed that the first order antinodes were kind of stripes. So the distances between the central maximum and each first order antinode are 50.4 centimeters and 56.2 centimeters. For the replica diffraction grating with the green laser, when I hold the replica grating a meter away and shine the green laser through it, we see the central maximum and the first order antinode on either side. I will turn the lights off and take the measurement so you can see what the values are. Data from the replica grating. We have the central maximum in the middle. The first order antinode on the left is 28.4 centimeters. and the first order antinode on the right is 26.7 centimeters. Glass grating with the green laser. There is the interference pattern. I'll collect the data for you. Once again with the glass grating, I've labeled the central maximum. We have a first order maximum on either side. The one on the left is 31.8 centimeters. The one on the right is 33.8 centimeters. We also identified a second order antinode for this one. We don't need to worry about the measurement for that. And then for the CD, acting as a reflective grating with the green laser, this is the interference pattern that we see. Okay, for the CD, as a reflective grating, we have a central maximum, and then the first order antinode on the left is 40.6 centimeters, first order antinode on the right is 42.4 centimeters, and we omitted the other of the second order antinodes because they're not relevant for this. Okay, the replica grating with the violet laser, 1 meter away from the board. That's the diffraction pattern. I'll record the results. Okay, the data from the replica grating for the violet light. Central maximum, first order maximum on the left is 21.3 centimeters. First order maximum on the right is 21.1 centimeters. The glass grating with the violet light, we end up seeing an interference pattern with several orders of bright fringes. We're just going to limit our data collection to the first order antinode on either side. The data from the glass diffraction grating, central maximum, first order maximum on the left hand side is 25.6 centimeters. First order antinode on the right hand side is 23.5 centimeters. Okay, the last diffraction grating we're going to use is the CD reflective diffraction grating with the violet laser. There is the diffraction pattern. I'll collect the data for you. All right, for the data collection from the CD, we have a central maximum. The first order antinode on the left is 31.6 centimeters. We ignored all of the other antinodes that we were able to see, all the other bright fringes. First order antinode on the right side is 30.7 centimeters, and again, we ignored all of the other antinodes or bright fringes on the right hand side. There's your data.